Before we start work on the spoke, we need to rotate some of these other elements so that we can get a more realistic view of the spoke in situ. So we're first of all going to look at this center area. So if we pick all of those objects, and then what we're going to do is hide everything else. So if we go into Object Display, Hide Unselected, we've then got everything else hidden. You can see the highlighting where we've got the selected object is white, but in some areas they're green, a light green, and that means there's some history there. So we want to delete that history because it's going to probably cause us problems at some point. So that's everything selected, but we don't want to rotate everything. We don't want to rotate these back surfaces here, for example, and we also don't want to rotate the curves. So we're going to hide those as well. So we selected the curves and those flat surfaces, and then in Object Display we can make those invisible as well. So we're just left with the surfaces that we will revolve. Now, to make life easier, it's best to group all of these surfaces together. So if we pick those, we are going to try and group those, and probably as usual it says can't group items with different parents. So what we have to do is do an edit ungroup, and while there's still some elements highlighted there, we'll just keep on ungrouping them until we're left with no picked objects. Over here you can see it says nothing's picked. Then we'll pick all of those surfaces again, and this time our grouping should be successful. So it's now allowed us to create that group, and you can confirm that if you pick object. So that's one object now. Now what we want to do is rotate that around so that we get a more complete view of the center hub, but we don't actually want to generate geometry at this stage. So what we're going to do is go into Edit, Duplicate Object, and open up the menu. So we want to copy it 4 times because we've got 5 segments that we want to create at 72 degrees about the y-axis, and rather than creating real geometry, which is what copy would do, we're just going to create instances of this geometry. So if I hit go now, we get this result. What does an instance mean? Well, if for example we pick this surface here, the other related surfaces are all highlighted. They're all dependent completely on that one surface. So if I then move that one surface, they all move together. And the benefit of that is that we don't have the weight of the real geometry slowing us down. We can also pick those. If we wanted to delete them, we can go and pick them as objects. Because we grouped the original one as an object, then these are all objects as well, so it makes them easier to pick and delete if we wanted to. So let's bring back all our other geometry. So we're going to go into Object Display Visible. That'll make everything else visible again. So we'll do a similar thing on the rim. If we pick that as an object, because we grouped it before, and you can see the pivot point seems to be over there, but just to make sure, let's go into Windows, Information window, just check that the pivot is at 0, 0, 0, which it is. So we can do the same thing again. So if we go into Object, Edit, Duplicate, Object, and the same parameters will apply in this case. The other one we want to do is this back face, which is the rear of the spoke R. So let's see if that was a group, which it is, yes, and again the pivot point seems to be at the origin, but let's just check that just to be safe. So there's the pivot point, and again we can go into Edit, Duplicate, Object. And notice that if I switch off that layer, it's actually using the same layer for those instances, which is very useful. One other thing that we might want to do is just change the color of that back surface so that we can see the contrast between it and everything else. So if we pick all of the objects on spoke rear, pick objects, go into Visualize, and what we want to do, rather than this rather white color here, we'll choose a really dark color. So I've got iron black here. Let's drag that down to here. So that's now selected. I'm going to pick everything on spoke R and assign that so that that's now black. What we need to do is then go and repick defaults so that next time we create geometry we get that color rather than black. And we'll now go back to the default workflow instead, where we're doing our surfacing. The first part of the spoke that we're going to do is based on this line here. So this line actually forms part of the rim, the front face of the rim, and then merges into the spoke. But it's one curve, so if we look at the CVs on there, that's one curve. So to create the front of the rim, we need to do a revolve. So we're going to pick that curve, 72 degrees as usual. Now this time we're going to pick on these end arrows to move the angle around. So we're going to change that angle, and up here you notice it says sweep angle 72 degrees, start angle 0 degrees. So we're going to make that minus 36 degrees as the start angle. So now our sweep angle is 108 because it's going from one end to the other. We can click on the other arrow and change the end angle to 36 degrees. So it's just another way of doing what we did previously, where we rotated the surfaces around. So that's created the front surface. Let's just take some of these other surfaces out of the equation, and we'll switch off the shading. Now the only bit of this surface that we really need, because it doesn't form the front of the spoke, it's just part of the rim, is the bit that goes from this intersect of these two curves up to the top there. So first of all, just to rough it in, we can use extend, and it will say, do you want to delete the history, which we do. So we're going to just drag that around until it's roughly in the right place, but we actually wanted to get it precisely on that end point there. One way of doing this is to, if we go into Object Edit, Insert, is to create a curve on surface that goes through that point. You'll find that some of the functions you can drag and use endpoints, in other ones you can't. This one is one of those that you can. So what we can do there is we can drag that line around, so this is going to be where our curve on surface is, but we're going to use this curve. So if we press Alt Control and snap to that curve, it actually snaps to the end of the curve, and then we press the space bar as usual to complete that. So that curve on surface actually goes exactly to the end of that curve there. And then we're going to go into Detach and press Go, and what we can do with that is we can move this edge back to where we want to detach the surface. So we move that around freely, or we can snap it to this curve on surface by pressing Control Alt. If you try and do that straight off the curve, it doesn't work, so we have to do it this way. So if we then press the space bar, we've now got two surfaces where there was one. Let's have a look at the CVs. So there's our two surfaces, and we don't want this one, so we can get rid of that. Now that's got a lot of CVs for a relatively simple shape, and we can approximate that very closely. So what we can do is go into Curve, Edit, Duplicate, put No Rebuild on, and pick that end curve there. Make sure it's on the end, because it does slide up and down. So if in doubt, just make sure that you move the cursor towards the left there, and then press Go, and that gives us that duplicated version of the end. So we've got a curve rather than an edge of a surface, and it's got diagnostics on it. It's saying that the maximum difference between the end of that surface and the curve is 0 at the moment. And then what we're going to do is go into that surface, and we're going to just drop the degree. Let's just, to prove that that is actually going to make a difference, if we go into degree 1 as a starting point, it says maximum 0.39, which obviously we don't want it flat. So what we'll do is gradually increase the degree. So that's much closer. It's almost within tolerance of 0.001, but we need to increase that a bit further. So now we're well within tolerance, 0.0001. So I now need to just complete that, hit the space bar, and we've got a surface which is very, very close to the original surface. We don't need that curve anymore, so we'll just delete that. So the other bit of the rim that we need to do is based on these two curves here. So we'll just go into those curves. First of all, just check that the pivot point is in the right place. So we'll just specify that it's at 0, 0, 0, and then if we go to revolve and we pick those curves, so that one and then that one, And this time we're just going to rotate those, so we'll pick those two surfaces and we're going to rotate those by -36 around the y-axis, deleting the history in this case. And then we can trim those back, those block surfaces. So we're going to trim, we're going to use project, so we're going to project that edge onto that surface, that's where we want to keep it. And then this one we're going to pick the surface, pick the edge and pick the bit that we want to keep. Let's just take all the CVs off there. And so let's have a look at the shading. So that's the bit of the rim that we've now got, and we want our spoke to merge into that rim, at that edge there. What we're going to do next is to rotate this rim around 5 times, so we've got something to compare the spoke against. As we've done before, we're going to group that together, so we pick those surfaces, edit, group. Can't group items with different parents, so we're going to ungroup that one. Ungroup it again. So we've got nothing selected now. Now we pick those surfaces and group it. So now there's no message up there. And then we can rotate it with duplicate on, and we're going to use an instance as we've done before. Make 4 copies of that so that we've got that as a background for our spoke. The spoke itself is going to be built off this one curve, and we're going to do that using a draft surface. So we're going to pick that curve there, and that's a draft surface with 0 draft on it, and it's in the X direction. So at the minute it's just completely flat, and we've only got degree 1 in that X direction there. Because it's the spoke, we can assign that to the appropriate layer, and we can also put symmetry on to see what the other half looks like. The only problem is we've got the wrong symmetry plane on, so it's making it symmetric about the XZ plane. Let's bring up the grid just to show that. So at the moment it's the XZ is the symmetry plane, and we actually want it to be the YZ. So to change that, if we pick the layer, make that active, and then if we go into layers, symmetry, set plane, we can then pick the plane that we want, which is, if you look there's 2 little grey planes there, and we want this one here. So that's now setting that to be the symmetry plane, and if we press the space bar we get that mirrored across now, that spoke. So let's just take the grid off, just get that out of the way. So there's our initial spoke, completely flat. We can't have that. What we should do to make sure before we do anything else is just to assign that, give that symmetry across that center plane. So we go and pick that edge there, so it's the draft surface that we want. So that's just telling us that that's symmetric. And if I go into the XForm function here, the reason we want to do that is in case we accidentally pick a hull that we didn't want, for example that one, and we try and move it, say, in the Y direction, it'll keep the symmetry across that symmetry plane at all times. We want some crown on this surface, so what we need to do is increase the degree to 2, and then if we pick the outer hull there and just move it slightly in the Y direction, we've got something with a bit of crown on it now. You can see it's not going to match up with the rim because the rim's a revolved area and the spoke isn't. What we need to do is to get those two to match, so we want to merge this into the rim at this point. So let's take the shading off, make it easier to see. And then if we go into trim convert, we're going to trim this spoke surface back to this edge here. So we're going to use project, we're going to use the Y direction, we're going to pick that surface, and then we're going to pick the curve or edge that we want to trim it to. For some reason it comes up and asks me twice, but you can see it's now put a curve on surface there by the green marks there. You can see that. That's the area we want to keep. We hit the space bar and we've got the trimmed surface, and if we come out of the function or pick nothing, then we've now got it trimmed. We want to make sure that's aligned, so let's go into align. Because it's only degree 2, it would be a very poor approximation probably to the rim. So we're going to pick that edge there, and we're going to try and align it to this edge here. So it's that outer one we're interested in. Now, because I've got partial on, it only matches it there. If I didn't have partial on, it tries to match to the entire width, which obviously we don't want. So we want partial on. If I take explicit off, it now matches it in curvature, but it's increased the degree, so that's not acceptable. What we want to do is put explicit on, and then we'll gradually increase the degree, so we've now got degree 3, and that's actually matched in curvature. And if we rotate that, because that curve was one continuous curve, although we've matched that, it hasn't come off that curve, because we knew we would have curvature continuity all the way through there, because they were both the rim and this spoke were built off that same curve. Now, one thing we do need to look at, certainly if this was an A-class model, is how good is that outer edge. It looks fine at the moment, but if we actually zoom in with a non-proportional zoom, you can just about see, and I've just moved that out of the plane, so let's move that again, just zoom it in again. So you can just about see there's a bit of a wobble going on there, which for A-class work is not acceptable. For CAS it would be perfectly fine. If it looks okay from a distance, it is. But for A-class we want to tidy that up. So one way to do that would be to create a straight line. So I've got a degree 1 curve here, and I'm just going to build it from this lower corner. So I'm using Control, picking that point, and then using the right hand mouse button just to give us a vertical line. I'll extend that surface slightly and just pull that out that way, and then if we go back into Trim Convert, again with all the same parameters in there, so we're going to pick that surface, that curve, and then that's the bit that we want to keep. So we'll come out of there, and you can see there's a slight wobble in those CVs, so we can planarize these holes here. So that's all nice and neat. And if we want to go back to the normal view, we just press on that non-proportional view scale toggle button over there. It's a bit of a mouthful. So we've now got our spoke in there. Let's shade that up. Now what we want to do is be able to see all the spokes at once, because that looks a bit wide, and we just want to see whether that is the case. So what we can do is we can take that one surface there, and if we check the pivot point of that, go into the information window, because of the way we built it, it's actually got a pivot point of 0, 0, 0, so we don't need to adjust that. And we can go into Edit, Duplicate, Object, and create instances of that one spoke, including its mirrored image, which is very useful. So now if we think that's a bit too wide, so let's extend that, the edge of that surface there. Just take it back a bit, and we can see the other spokes all updating. So we just thin that out until we're happy with the thickness of those spokes. So about there. So that's the front surface of the spoke created. The side surface we're going to create again from the draft surface. So let's pick this edge, and you'll see that because we've actually got spoke F selected, it's already putting this surface into that layer, which is good because we're getting the mirror image across the other side. But we want to send this draft surface off in the Y direction with a bit of draft angle on it. So although the minimum is 5 degrees, we might want to make that a little bit bigger. It's as much driven by the aesthetics as the actual engineering requirement. So I've put in 10 degrees there, and that's created us a nice side surface. Again, on the side surface, we don't tend to want flat surfaces. So on this side surface, we're going to bring up the CVs here. We're going to increase the degree to 2 and accept that. And then we're going to just move that centre hole out a little. And we want to move it in the X direction. So at the moment we've got X locked. So we move that hull slightly in the X direction to give us a bit of crown on that surface. The final thing we need to do for these spoke block surfaces is just to check the draft angle. So if we go into Object Display and open up the diagnostic shading window again, we can put draft angle analysis on here. We need a draft angle of 5 degrees, a tool direction of Y, and we can see that that's actually coming up as all green. So that's good news. If we look at the back here, it's actually red, but that's ducking below the surface of the back surface, so we're okay. If it wasn't okay, then we can just go in and pick this hull, for example, and just flatten that off a bit. You can see if I try and make it too crowned, we're now causing an undercut condition in terms of the draft angle. So as long as that's green, then we're okay.